most of you are, I think, currently looking for jobs or applying for jobs, or thinking about choosing between different careers. And today we're going to mostly talk about this aspect of your future career and how to learn more about jobs and how to train yourself in those respective fields. So just as a general thing, although it may not hold 100% true, but any class or teaching that you get should have some kind of implication for your future. You should get something or learn something useful that you either directly apply, like statistics or math, in a project, in a useful project, or it should have some kind of an impact. And today we're going to talk about the impact of this particular course that we have. As I said, most of you are currently looking for jobs and maybe considering several titles. The titles can be anything like engineer, researcher, scientist, developer, different job titles. And it's first a good step. Your first step would be to do a research of what these jobs are, what the details are, what the tasks are. And so at the same time, you need to know about your own potentials, your own capabilities, your own skills, your own interests, particularly, so that you know what kind of jobs or what specific jobs are more suitable for your own specific personal case. So you need to start knowing about yourself. You can just write down your interests and just what you like, whether you like certain video games or whether you like troubleshooting or working with systems or social activities. You have a better idea of what you're good at yourself, and you need to think about that. And after this first phase of self-discovery, of knowing yourself and your own potentials, you need to think about potential jobs that you would like to have for your futures, and do some research to learn more about what those jobs are and what their characteristics are. So first we need to learn about, after you learn about yourself, we need to learn about your different jobs. So we do job analysis. And now I want to ask if you remember task analysis and what task analysis is. Can any of you tell me what task analysis is? Yes.
Breaking those tasks into further detail.
Yes, breaking a task into its own details. When we have a task like troubleshooting, we break that task into individual behaviors, the smallest levels of human activity, and that is called task analysis. And the result would be, for example, at this step, you would think about this or move your hand this way or look at this part, and those are small details. And it's just like that. Job analysis is task analysis, but in a higher level. So if you think about a job like software engineer, mechanical engineer, scientist, or anything, that is composed of different tasks. And each of those tasks are composed of certain behaviors. So in this level, job analysis is task analysis, but that is conducted for jobs. And the result would be certain specific tasks that a person implements or conducts in a specific job. So the formal definition would be analyzing a job to its single tasks and responsibilities. So we basically analyze a job. And what it does is that it gives us an accurate information of what a job is. We hear somebody is engineer or somebody is scientist or researcher or teacher or anything, but we don't have an accurate idea of what they do. on a daily basis because we never had that job. So in order to have that accurate picture, we do the job analysis to know about that, to know about their daily activities, their specific responsibilities, and what they do actually in the job. So just for an example, you can imagine a software engineer. And if we do job analysis for software engineer, the result would be certain tasks. One task is, for example, writing a code in a programming language or multiple programming languages. Another task would be troubleshooting a faulty code or a program. If there's something wrong with the software that you develop, and you have to be able to find the fault. Another responsibility would be meeting with managers, talking to them, talking to different teams. If you're in a software company or one of these big tech companies, there are different teams for UX designers. There are different stakeholders, there are customers, there are managers. You have to be able to communicate with them. So you also need some social skills, communication skills. And also another responsibilities would be to talk about, to have some kind of a skill in project management, that the manager comes to you and tells you to add this feature or to develop this tool. And you need to have an estimate about how long it takes and how much energy and people it takes to do that. That's another skill that only you gain it with experience. So these are some examples of the type of tasks that a software engineer would need to be able to do. And we can just go on, list other tasks, but it's just a general picture of task analysis for software engineering. Another example is user experience researcher or UX researcher. And if we analyze the job of a UX researcher, it would be a task like when we have like a product, like a software or system, when recognizing when we need to conduct a user study. And so you are in a software company, you want to introduce a new interface, and you ask the UX researcher that whether this interface is usable or not. How much is the likelihood of users making a mistake or having a failure or error in using this tool or interface? Another task would be, how many participants do we need? For example, we reviewed some cases in developing training simulators, and we talked about the experimental method. We design an experiment, and then we need to know how many participants to enroll for that specific experiment. Designing an experiment itself, how to divide participants, what conditions to have, what groups of people to have, and actually implementing the research. So, and in the end, collecting the data, analyzing the data, using statistical tools, these are all different tasks that a UX researcher needs to know and needs to do in his or her job. So you can see that if we break down a job like a software engineer or UX researcher, you get like these specific tasks that that person needs to do. Do you have any question about this basic idea of job analysis? Job analysis is a very broad concept, and people in various disciplines use it, like from industrial and organizational psychologists to management and managers, because even in training programs, they need to conduct job analysis for managers because they need to know if their employees' payment is corresponds to their amount of work. And so in any organization, maybe the managers need sometimes to have someone conduct this job analysis for their employees. So it can be very broad, and the reasons of conducting job analysis can be different. But here we are focusing more on this specific human development aspect. So the question is how to conduct job analysis. And again, I would encourage you to think about task analysis. And if you remember conducting task analysis, there were multiple methods of collecting data for a specific task. The first one is conducting interviews with people who have that job. So you select people who are currently software engineers, for example. You sit with them, you ask them questions about their daily activities. You ask, what do you do in a daily basis, in a typical day? And also asking questions about what if the manager comes up with a new project, what would you do in that case? And different scenarios to get to the specific responsibilities that they do. The second method would be to prepare like a structured questionnaire and give them to fill. In that way, you can have, when you collect the data, because interviews are very unstructured, that's why they're usually called qualitative in nature. And analyzing and learning about that data is a bit challenging because it doesn't have that kind of a structure, and it's difficult to quantify that data. So one way to make your job easier is to prepare structured questionnaires that they can fill, and so you can have a better structure for your data. And you can have like yes, no, or other questions that you can basically count, and your statistical analysis would be easier. Another one is diary studies. So you basically tell them to write down their daily activities. They get up in this time in the morning, they go to work at this time, they have a meeting at 10 a.m., then they have XYZ, and they just go until 5, 6, or whatever time their job finishes on a daily basis. And just like task analysis, another one is which gives you a direct picture on their job. And the method that you can always rely on is observing people at their jobs or video recording them. So you have like a work environment, you can install a camera or something like that. And then you can record them or observe them directly. And then from that video recording, you can just see how they spend their time. Whether they have meeting, they're coding, they're fixing a tool or anything like that. Always observing a video recording is considered as an expensive method of data collection. It is time consuming, it needs extra equipment, but it is considered as the most accurate method. And this is not only in our course, but also in design courses, in ethnography, as is known as ethnography in fields like HCI and HCD. So we have these methods of conducting a job analysis if you yourself want to do that and collect data. But you can cheat as well. And how you can cheat is by using available resources. It's not real cheating, but it's kind of finding an easier way to collect data about jobs, especially about more established jobs, like mechanical engineering. It's obvious that in an abstract scale, most mechanical engineers should know about XYZ and they're responsible for such and such. And this is shared between all mechanical engineers, regardless of whether they work in this company or that company. So there are some available resources on internet that you can use to gather information about jobs. And the first one is ONET. I don't know whether you've ever heard of this resource, but I'm just gonna show you how this it's a website basically that has all the job titles, almost, not all, but a lot of job titles. And it contains text-based descriptions of the responsibilities, the characteristics, requirements of different jobs. And it is developed and maintained by US Department of Labor. So this is the online website, onetonline.org. And here you can just search for any title of any occupation. So I searched mechanical engineer before. You can just search this title and you can see that anything related to mechanical engineering also shows up. But you just choose mechanical engineers, and then it gives you a summary report for this job. And this is the official code for this, and all the details, like the tasks that a mechanical engineer is responsible for, technology skills that are needed for that, like even specific softwares that a mechanical engineer needs to know. So about knowledge, skills, and abilities, you can see the details, specific work activities, working with computers, making decisions, and things like that. A lot of it is shared between all engineering majors, but there are also some specific things about mechanical engineering. And you can see that how many people from bachelor, associates, some college, no degrees. So you can see basically the educational level of mechanical engineers. And you also see their payment even. So all the details that you can see about a job, you can find it here. And it's pretty much a comprehensive resource as far as I know. And it is used again in IO psychology and other disciplines as well. So that's just one resource that you can use for collecting information about jobs. One thing is that this ONET is text-based. So whatever you see is textual descriptions of jobs. Another one is Career One Stop. And this one contains videos or documentary-like videos of different jobs. It is not as comprehensive as ONET, but it instead gives you a video. And I think the kind of information that you can get from the video is something that you cannot convey with text. Like you can show the equipment, you can show the workplace, you can show the environment, the people, what they wear, and all the details. So we can just take a look at this one, and you can search, for example, industrial engineer. And you can choose industrial engineer career videos here. And you see that you can just play the video.
While originally focused on streamlining manufacturing processes, the field of industrial engineering now includes processes and systems in virtually all industries to make them more efficient, yielding less waste and costing less. To maximize efficiency, industrial engineers balance many factors, such as the number and type of workers involved in the process, available equipment, safety, environmental impact, and cost. They might design faster production methods, choose new materials to make longer lasting products, or devise ways to move customers to a line faster at an amusement park. Some engineers focus entirely on automated manufacturing and work with robots and computer networks. Industrial engineers often rely on teams to identify problems and solutions in their work. They generally work in offices or travel to the settings they are analyzing to identify improvements. For example, they may want workers to assemble parts in the factory, then return to an office to analyze the data they have collected. Most industrial engineers work full-time, but hours may vary depending on the needs of specific projects. Industrial engineers need a bachelor's degree in industrial engineering or related engineering fields. Employers value practical experience in the field, which many programs offer as part of a degree program.
So you saw that they talked about industrial engineering. They talked about, without mentioning this, but they cover different types of projects that they do. For example, typical industrial engineering is divided into three sections. One is optimization, how to improve the efficiency of, say, lines in an amusement park. Another one is manufacturing, which is basically manufacturing in a manufacturing plant, improving the processes in that, and human factors, which is mostly about design. It kind of mentioned these three aspects. They also mentioned about work setting, about their being full-time, and other details that is kind of a very short, but it shows you the kind of context and the places and locations that industrial engineers work in. So these are some available resources that you can use. These are just two examples, but you may also be able to find other resources to collect information about jobs. And as I said, these are created and supported by US Department of Labor. Do you have any question about that? Yes.
So at least from my experiences and experiences of friends, a lot of government supported websites tend to be outdated and difficult to navigate. Did that apply to these or are these
Based on my experience, they were relatively easy to use. Because as you saw, you just search the title of that occupation and then you see the result and you just, but you're right in a sense that I've seen some cases, some websites even related to this job analysis that they weren't user-friendly. And I've also seen government website that is not as user-friendly about other things, but not particularly about this. Maybe Department of Labor is better at making user-friendly websites. But yeah. Any other question?
This is more comment than a question, but one thing I want to know about that is people that is a data occupation by state, by city.
Yes, exactly. It has the statistics about like, also about like what jobs have a bright future, what jobs are growing, like in what locations. They divide jobs in like states, cities, locations, and all other details that you can find. Yes, I think Own It is a very comprehensive website in that respect. And they update it every year or so, as far as I know. So one thing is that, as we saw, you can rely on these available resources, but there is one problem in using these available online resources. Can any of you tell me what that problem is? Yes.
Imagine some deviations based on where you end up working.
Yes, exactly. So the specific place or position that you are applying or considering is a real job in a real company, in a real team, on a real specific product. And it might differ with another person's job with the same job title that works in a different company in a different setting or location. So that's the problem of relying too much on this information, because these resources that we saw, they're basically abstract. They try to cover all mechanical engineers, for example, or industrial engineers. So they can be a bit inaccurate when you apply them to real jobs. So as I said, they do not talk about specific companies, teams, managers, culture, and specifically values of an organization. They just tell you about titles. And when it comes to practice, they are too abstract. Yes.
I just want to point out, like, it also could be too detailed. So, like, if you're want to be mechanical engineer exposure, you have to know all of these different languages and tools. Might be intimidating and think you need to know everything.
Yes. Yes, it can be intimidating, and at the same time, it might. I mean, the specific requirement of a company might be different from another company. In one role, you might need to know about certain tools and softwares, but in another company, you may not need those, but need other tools and softwares. So some of the things that you may want to know, and these available resources do not tell you, is your specific daily activities. Whether that specific job needs travel or it needs physical activities, for example. Another aspect is your specific working hours and whether you will be on call or just work 9 to 5. Your work setting. The location, tools, other people, of course, they're different between different positions. And also some other broad considerations like organizational values, like even their political affiliations. Some people care a lot about this, work in companies that align with their own political orientations or preferences. Or another example is environmental impact that that company is having. So just to give you an example that I'm aware of, if you look for a job like human factor scientist, the type of jobs that you would see is one can be, for example, in forensic sciences. You are human factor scientist, but the kind of investigation you do is that there is an accident or a catastrophe or some problem, an accident that happened, like a fire, a traffic accident, and you go to the scene to investigate how human involvement caused that accident or problem. So you collect data and then you come up with some hypotheses to see what happened, what actually happened. That's one type of roles for human factor scientists. Another thing that a human factor scientist can do is to work for companies that develop products and to get involved with the design and development of that product and to give insight on how usable those products are. So as you see, this one is different from the previous one. The previous one was more retroactive or determining the cause of what happened. This one is more proactive about designing something. Another one would be working more on ergonomics, that how to design a work setting. What should be the distance between your eyes and the monitor, for example. And lastly, the design of medical equipment. You can work in a medical company and get involved in the design and usability of medical or surgery devices or medical settings. So as you can see, the same title, human factor scientist, can be involved in this various different kinds of projects. And that's why that those available resources may not give you a direct picture on that specific job. So the best idea would be to use those available tools as the first step, if you do not know anything about that job, to gain some general familiarity, or use it for knowing about the job and its statistics. And then you have to conduct an analysis yourself to collect information about specific positions, companies, teams, and that specific job. And based on my experience and knowledge, the most common strategy is to talk to people or employees in that company that you're applying to, and contacting their employees and also managers, hiring managers. They are the people who would give you a better idea about the specific responsibilities that you will have in that job, about the company, about the type of projects that they work on, and other details. Do you have any question about job analysis, available resources, and doing it yourself? Okay, so that idea of job analysis is to learn about jobs. Once you know that you have enough information about the job and you have an idea of what job you want to pursue, then you want to train yourself, whether you are already employed by a company or just received a job offer. You want to train yourself on these responsibilities and tasks that are required for that job. So you have the result of job analysis, all the detail and information about the job in front of yourself. And it is composed, usually, it is composed of certain technical skills that you should have, general knowledge, and some other social skills that may also be required in the job. And once you know about that, you need to train yourself on them. Now, the company may train you, or you want to start earlier and train yourself on it. Just to give you an example, imagine as a part of a technical skill that you might have, that job requires you to use the software Matlab, which is a programming software that is mostly used in engineering domains. And suppose you do not have any idea of what Matlab is, you never worked with it, and you don't have that much background in programming. How would you go ahead and train yourself on it? How would you start learning Matlab? Any idea? Yes?
I would love for any resources that might be able to use to learn it that already like books or information.
Using available resources and online courses. Yes?
Well, if you know that you're going to have to use it for a fact, which you should probably figure out your analysis. Start out like downloading, you know, and just kind of playing around with it a little bit.
So you can download the software, playing with it to see if it's, to at least gain some basic familiarity with its different parts, what sections it has, or that kind of thing. Yes? Okay. Yes, you can watch some YouTube videos about basic programming with Matlab, or it's how to start using it. Mhm. Yes, and of course, in that job, if it requires you to know MATLAB, it's very likely that some of your coworkers already know more than you about MATLAB, so you can ask them to guide you or help you. And yes, but if we want to go like step by step, first of all, you have to familiarize yourself with MATLAB as a thing, as a tool. Like, what is it for? Why it is used in that job? What is its input and output? Why do we use it in that job? So, for example, we have some data and we want to know something about that data. We use MATLAB. That's why we use MATLAB. That's the basic idea of, or the reason, knowing about the reason of why we use MATLAB. That's the first step. And then, because using MATLAB without having any programming background might be a bit daunting or might be a bit user unfriendly, you may just learn or use a simpler programming language. Like one of you gave a presentation for your final project presentation about using a simple programming tool just to train yourself for programming languages or programming in general. And that can be the first step, to use a simulator that is used to train basic programming, learning about variables, blocks, loops, conditions, and things like that. And then you can just work with MATLAB, familiarize yourself with its environment, like defining variables and other things. Again, there is no like a single best solution to do that, but that's just to start from simpler steps would be a better idea that might facilitate your learning of MATLAB. Because we also need to consider that those people might have basically zero familiarity with it. All of us have some general knowledge about like computer programming, uses software, statistical tools and things like that. But those people might have basically zero knowledge about it. So the basic idea is to start from simple to more complex. And yes, it's always better to start from simple, or if we have simulators, start from low fidelity and move toward more complex tasks or high fidelity. Now, if there is no simulator, we can think about simpler tasks or problems and moving toward more complex problems. So as we discussed throughout the course, the direction is always from low to high fidelity. And that was for technical skills like coding, but you can also think about specific problems. Just consider the case of security analysis as a job. So you know that you're going toward that direction. First of all, I mean, as like basic training, you need to familiarize yourself with basic or simple scenarios of security issues. Just like in the courses that some of you might have passed, or even in statistics for security risk analysis, they present you with cases that say, for example, we have this company, now there's this issue, we have this many data, and they do not present you with a complicated security attack or something like that that might have multiple aspects, and you don't know where to begin to analyze that problem. So first would be a simple scenario. And then when you practice more with simpler scenarios, you know that you're getting better at them. And then you can just move toward more complex issues and problems. because then you would learn how to break them into different problems and to start from one and move to the others. Do you have any question about that direction from simple scenarios and tools to more complex ones? So we should always remember to make effective use of low fidelity materials. And just as what we talked about in the class, imagine you have a part of your responsibility is troubleshooting. You can use those abstract low fidelity materials that we talked about in class to train yourself on troubleshooting, because they were like general materials that you can just, if you practice with them, you get better at general troubleshooting, and then you can move toward more specific troubleshooting problems. Especially if you do not have that much background and experience in troubleshooting. It's always safer to start from low fidelity materials. And as we saw in more high fidelity materials, then you get to know about the specific systems that you are responsible for their troubleshooting, to learn about their basic functions, different parts, their names, the likelihood of failure of certain parts of the system, and all other details. And just like low fidelity materials, we should also make effective use of high fidelity materials. One thing to remember is that it's always, you should always remember that you cannot jump from low fidelity materials to the actual target environment or target system. So before starting, you need to go through high fidelity training for more complex problems that are very similar to the target system and environment. As you can see, we are making some general conclusions of what we've already learned. And high fidelity training does not always require simulation. We talked about high fidelity simulators, but it can also be something like on-the-job training. So you're starting a job as a novice, and they give you the exact job and responsibility in the target environment with the target system, but you are basically in the training period. And you learn by doing. And that can also be considered as high fidelity training. It's basically the target system. It's no longer simulation, it's the reality. But you are not expected to produce just like a regular employee or operator. So this concept of on-the-job training is something that is used in many different fields, and this is the same thing is used here, that you learn along the way as you are doing the job. And one value of doing internship as a student, especially in summers, is this, that you go to that work setting or environment and you do the actual job. And you get the experience of how it looks like, you work with target tools, target systems, target environment, people, everything's real. And so you learn by doing. You learn the job on the job. Do you have any questions? Okay, so the last thing to talk about is social skills. So whatever we talked about by now, they're all technical things, technical skills like coding, like knowing about specific things and responsibilities. But most jobs that you will enter, they need social skills or social or communication skills. And despite some of you might think it is very important, talking to managers, talking to your coworkers, knowing when to communicate, when to report, these are all key aspects of the job. And they include things like speaking in public or to the team, like coworkers, to managers, to stakeholders. Collaborating is another social skill that you need to know about. And one example can be how to divide a specific task to different people. And so they would do that, and then you coordinate between them. Or there is one problem and you have several people working on the same problem, giving new ideas, or basically collaborative work. Any type of collaborative work. Another thing is to understand the inner working of your own organization. So imagine you have a job and you don't have any idea of what you're working on, who you're working for, what section of the company you're in. And that is problematic because usually when there is meeting, you need to know about other sectors of your organization as well. And that is also considered as a social skill because you need to know about other people and what they do, their team is responsible to do. And also understanding the outer working of your organization, its relation with other companies, whether there is a competition between companies or long-term strategies of that company. So generally, these can be categorized as the kind of skills that is not specific to that responsibility that you have on a daily basis, but is more like broad knowledge or social knowledge that you need to have. So the question is how to train yourself on those social skills. And this is more difficult because there's no simple answer to that. It depends on individual cases, personalities of people that vary widely between individuals, their learning style, and this plays a crucial role, but as just some general tips, there can be some examples. For example, for improving your public speaking, you may want to volunteer to participate more in classes that you have, for example, to talk, ask questions. If there is a voluntary presentation, just take the lead and present in class. So these are all practices that you can have to speak in public. Another one can be, again, just like engaging yourself in discussions, like asking questions, giving comments, any setting that is social and you can talk. Now it can be class, it can be church, it can be any gathering, any group of people that you can talk to, even your relatives. Another example for improving your collaboration and coordination, you can, I know that some of you are a member of student clubs or are a member of student organizations, But these are some voluntary responsibilities that you can have to improve your social skills. So it is not directly relevant to your courses, grades, but you are a part of a team that has a cause, has a goal. And these groups or organizations can be political, environmental, they can be planning for events. They may be advocating a cause. And of course, it's extra work and do not pay off in a short term, but the things that you learn by being involved in those organizations will definitely pay off in a longer term. Because you learn these skills unconsciously and how collaboration in a team works, how to communicate with other people, how to plan for an event and things like that. So I would definitely encourage you to start and join such teams or such organizations that you can be a part of. So in summary, for whatever we talked about today, you will first need to learn about yourself, your potentials and your interests. Then, for the kind of jobs that you might be looking for, you do the job analysis and you learn about potential jobs that you want to apply to. And then you do the research about the specific companies and specific positions by talking to people who work in those companies. And finally, you train yourself on both its technical aspects and social aspects. Can be with using simulators, tools, or with social activities, just what we talked about.